September 26, 1905. The German journal Annalen der Physik publishes a paper titled On the Electrodynamics of Moving Bodies, signed by someone named Albert Einstein. The name means nothing in scientific circles. Few know it belongs to a 26-year-old who doesn't work at a prestigious institute, but writes his papers in the evenings after his day job at the patent office. It's already the third paper he's sent to the journal this year. This one, to the editor's surprise, presents the special theory of relativity, set to turn our view of the world upside down. And even that isn't all. Just one day later, on September 27th, the editors receive another of Einstein's papers, this time introducing the revolutionary equation E equals mc squared. All four papers published in 1905 will upend scientific thinking and make Einstein one of the key figures of the 20th century. But recognition won't come right away. His ideas will face a long uphill battle. Albert Einstein was born in 1879 to a Jewish family in the German city of Ulm. For a long time, he reportedly didn't speak, and his parents feared for his mental development. At age 5, his life changed thanks to a gift from his father, an electrical engineer, a compass. The invisible force that moved the needle filled him with wonder. From that moment on, he focused almost entirely on physics and math. Even in elementary school, he excelled in these subjects, so much so that his teachers couldn't keep up, and he let them know it. This would remain a pattern throughout both high school and later at the prestigious Polytechnic in Zurich. And so it happened that when he graduated in 1900, he was the only one in his class unable to find a job in science. Though clearly a genius, no one wanted to work with him. And yet, while Einstein may seem a bit odd, he'll become known, for instance, for his messy hair and refusal to wear socks. He's otherwise a friendly social man with a strong sense of justice and a deep aversion to war and violence. He also has a certain spark in his eye, one that over the years wins over more than a few women. At university, he's the one who manages to win the heart of the only woman in the class, Serbian student Mileva Maric, and even gets her pregnant. That's a problem. He ought to marry her, but he still has no income. Only after 2 years does he finally land a job as a clerk at the Swiss patent office in Bern. The position is well below his scientific potential, but it has its advantages. Einstein is tasked with evaluating physics-based inventions submitted for patents, placing him on the front line of cutting-edge discoveries in electrical engineering. And since he handles his job with ease, often correcting the patent applications himself, he has plenty of time to focus on his own ideas and theories. From a young age, he has felt that the existing laws of nature, unchanged for some 300 years since the time of Newton and Galileo, no longer match the current level of understanding. With no access to a laboratory, everything takes place in his mind. He thinks, for example, if he were riding on a train and turned on a flashlight in the direction of travel, the beam would shoot out at the speed of light. According to current rules, the speed of the train should be added to that of the light beam, meaning the beam would move faster than light itself, which was already known to be impossible. So where's the mistake? Einstein realizes that existing physics starts to break down at speeds approaching the speed of light. So he sits at his desk, and while his new wife Mileva takes care of the first of their 2 sons, he fills sheet after sheet with equations and calculations. By 1905, his work is ready. He begins sending one paper after another to Annalen der Physik. The first explains the principle of the photoelectric effect, a phenomenon that will later enable things like photocells, lasers, and solar panels. In the second, almost in passing, he clarifies the so-called Brownian motion of atoms in molecules, providing final proof that atoms truly exist. On September 26th comes the paper that introduces the special theory of relativity. It claims that at extremely high speeds, the usual rules about fundamental quantities, like length, speed, or time, no longer apply. For example, if we observed an object moving near the speed of light, it would appear shorter to us, and time would pass more slowly for it. The time part is easier to imagine. Satellites orbiting Earth already move fast, and high enough that time flows more slowly on them than on the ground. The difference is only 7 microseconds per day, which seems tiny, but if this shift weren't factored into GPS satellite systems, your navigation would be off by a full kilometer, making it completely useless. In the final, fourth of Einstein's papers from that pivotal year 1905, he presents the now famous equation E equals mc squared. It states that the energy of an object equals its mass multiplied by the speed of light squared. In other words, every kilogram of any material contains an immense amount of hidden energy, most of which we still don't know how to harness. The theory's accuracy will be confirmed in 1939 with the discovery of nuclear fission, and later with the atomic bomb, which can level entire cities and kill hundreds of thousands using just a few kilograms of radioactive material. But back to Einstein. He expects his flood of papers to cause a major stir, but almost nothing happens. His theory of relativity is simply too radical, and it will take him another 15 years of work to gain wider acceptance. Fortunately, he earns enough recognition to leave his job at the patent office. After brief stops in Bern and Zurich, he finally secures his first real academic post, professor of physics at the Charles-Ferdinand University in Prague. Einstein spends 3 semesters in Prague, teaching 5 to 7 hours a week. But students gradually drop out, as Einstein devotes more time to discussing the questions that interest him than to formal lectures. Chief among them, expanding and proving the theory of relativity. After another stop in Zurich, Einstein moves to Berlin, where he settles for many years to work at the Humboldt University and the Prussian Academy of Sciences. It's here he falls madly in love with his cousin Elsa. His wife Mileva agrees to divorce him only on one condition. Einstein must provide child support for their 2 young sons. But Albert is still broke, so he makes her a bold offer. He's so sure he'll win the Nobel Prize for his theory of relativity that he promises to give the entire $1 million award to support the children. Mileva knows it's a gamble, but she agrees. This puts Einstein under enormous pressure. He must succeed, or his children will grow up in poverty. So he adds to the special theory of relativity by developing what's known as the general theory of relativity. In it, he tackles another major force, Newtonian gravity, which he argues also breaks down at high speeds. Einstein says, for example, that Earth doesn't orbit the Sun because of the Sun's gravitational pull, but because the Sun, like all massive objects, bends the space-time around it. And space-time is, at this point, a brand new concept in physics. At first glance, it sounds insane, but this time, Einstein comes up with a way to prove space-time curvature, even to non-scientists. The idea is this: when we look at stars at night, their light travels straight to our eyes. But if the Sun is in that same spot during the day, its bending of space-time should cause the starlight to curve on its way to Earth. As a result, stars appearing right next to the Sun should seem to shift their position. Einstein even calculates the precise amount, 1 3/4 arcseconds, and how to prove it, with a photograph. While photographing the night sky is easy, doing it during the day requires waiting for a total solar eclipse. Only then can stars near the Sun become visible. The problem is that solar eclipses are rare and always visible from different, often remote, parts of the Earth. The next chance comes in the fall of 1914, in Crimea. But World War I has just begun, and when Russian authorities find a group of international astronomers there with huge telescopes and cameras, they accuse them of espionage and throw them in jail. The next chance comes 4 years later, in 1918, this time in the United States. But American astronomer Campbell lacks the proper equipment and fails to detect any deviation at all. It looks like Einstein's theory might collapse. Just a year later, as Campbell presents his results to the scientific community in London, Einstein gets incredibly lucky. A telegram arrives from another research team. This time, it's British astronomers Arthur Eddington and Frank Dyson, who had travelled in May 1919 to photograph a solar eclipse near the equator, one to the island of Principe off Africa, the other to northern Brazil. Both return with the long-awaited proof. Every star near the Sun appears exactly where Einstein predicted. Space-time is curved, and Einstein's general theory of relativity is real. It's a complete shock. Suddenly, Einstein is everywhere in the news. The man once seen as a mere dreamer has rewritten the laws of physics that stood for centuries. So when Albert Einstein arrives in the United States for a lecture tour in April 1921, 15,000 people welcome him in New York. A legend is born. The most famous scientist of the 20th century.